Welcome back Year 10s to this next video. In it, I'm going to show you another method of regression. Now, just a reminder, regression is where we fit a line to a scatter plot. So you remember a couple of lessons ago that you had a scatter plot here. Mine's not fully filled out, of course, but you had a line that went through your scatter plot. And what you did in that lesson, in a previous lesson, is you tried to fit that line in a spot that would best fit that data, so best model that data. So the line that we put on it is called a regression line. Now that method that we used then was putting it on by eye, but I mentioned that there are other methods of regression. And the one I'm going to show you now is using technology. And this is the most common way of finding a regression line because, of course, it means we're not going to get different answers. Say if you were to fit a regression line and I fit one, we could possibly fit our lines in slightly different spots. This is a mathematical process that fits the line in a particular place, and it does that based on something called residuals, or more specifically, the least squares of those residuals. Hence why we call it the least squares regression line, which is our title just here. So this is a particular method that is best used or best found using your calculator, hence why we say the CAS here. We use a CAS calculator to find it because as I explain how it's found, you're going to see that it is quite complicated and it would be very difficult to do by hand. So this least squares regression line, which the calculator is going to give us, is basically going to fit the data so that we've got basically minimizing something called the sum of the squares of the vertical deviations. Now, I'll explain what that means. These vertical deviations, if you have a look at this diagram just here, notice how in the solid or the darker green, there's these vertical lines. Those vertical lines represent how far is our data from the line that we're placing on the scatter plot. So you'll see it is a vertical distance because it's how far in terms of the response variable. So it's a distance that we get from this axis over here. That's, of course, our response variable axis. And it's telling us, like I said, how far apart was our dot or our actual value. This here is an actual value. Might put that on here. This red dot. I'll just explain what I'm talking about. This red dot here is an actual value. So that came from the data. Whereas this line here is a regression line. That's what we're using to model the data. So a regression line. So this bit here is the vertical distance between the line and the actual value. In other words, between the line and our dot, our red dot. How far apart are they? And finally, what we also need to understand in order to understand the least squares regression line is that this here is a square using the side length of the vertical deviation. I probably could have worded that better. Square using the side length equal to the residual. Now, the residual is that word that we use for this vertical distance. So I'll just put that up here as well. A residual, vertical distance between the line and the actual value. And this here is a square made from that vertical distance. So it's got the side length equal to that vertical distance. So this is a square here. So now that we've established some of the key things, what we would want to do if we're making a least squares regression line is we'd want to put this line in a particular spot that would minimize, so make as small as possible, the sum of the squares, so sum of the areas of these squares. So in other words, if I move that that line too far away from my dots, I'm going to get really big squares. And of course, when I add those areas together, I'm going to get really big areas. Now, I don't want that with a least squares regression line. I want this line to be really close to the dots, as close as possible. And so the smaller the squares that I've got, the better. Now, if you've got dots that are right on the line, that means that they've got a residual of 0. So there's actually no square even in that particular spot. Now, this one doesn't look like it's quite on the line. So the square formed by this one is very, very small, and it's so small that we can barely even see it. Whereas this dot here is quite far away from the data, so it creates a really, really big square. So we want to place it in a spot that's going to give us little squares, so that when we add all of those squares up together, we get the minimum possible. Now, can you imagine trying to do that by hand? That would be a nightmare. You'd be placing your line in a particular place, making all of the squares, finding all of their areas, adding them together, moving your line to another spot, and then doing it all again. And so as you can see, this particular screenshot has come from technology, so it's been done using a computer system, and we have a computer system in the classroom with us, and that computer system, of course, is our calculator. And so what we're going to do is we're going to use our calculator to find the line. So the line, you won't see the squares when you put it in, and that's because we don't really need the squares. The squares are sort of there, they're in the background, but that was just to place the line, and the calculator has done that for us. So we can have trust in the calculator that once we fit that least squares regression line, it has done so using the squares of those residuals. I'm going to show you how to get it on your calculator, and then you're going to be able to practice these steps. So it is outlined in front of you on this sheet that's in your notes, but I will show you with some data that we used previously as well. So back here, we had some data that was on time spent studying and a test mark. What I've done is I've put that data into the calculator. Notice I've got time is labelled, and then I've gone down this column and put that in, and then I've got mark labelled as well. So all of the data needs to be entered, and it needs to be paired up as well. So for example, a person who studied for 2 hours got a mark of 54%. Now, to create your least squares regression line, just note there are a couple of ways to do it on the calculator, but since you're learning, I'm just going to show you one way for now. You will start to learn of the different ways next year and the year after, since we do this so much in this subject. So we'll go Control and then I, because we want to add data and statistics. We are going to create a scatter plot, which we've done in a previous lesson. We're going to put the time spent studying as the explanatory variable, because what we're considering, what we think is that perhaps this may be having an effect, possibly, on the mark that you achieve. So there we have our scatter plot. We can see that the dots are drifting upwards. That, of course, means we're looking at a positive relationship between the variables, or positive association. If I want to model this data, I can put a line on it. And this particular method is going to do so in a mathematical way. So we're going to press on Menu, and then we're going to go number 4 for Analyze. Now, when you go to Analyze, you'll see a word that I've been using. So have a look at number 6, Regression. So you're going to go to Regression, and then you're going to select this one here, Show Linear mx plus b. Now you can select the other one as well. All that's going to do is put it in a different order. It's going to put the y-intercept first, and then it's going to put the gradient and the x term second. It doesn't matter which one you do, as long as you, when you are copying it across, that you are doing so accurately. So if we have a look back at your instructions that you've got in here, you'll notice that we've got here to select mx plus b, which is just like saying it's in the form y equals mx plus c. Same as that, but they've just used a different letter for the y-intercept. So I'll do that now. Just go up to the top. There it is. And when I click on it, you'll notice that this equation comes up straight away. If you have any trouble seeing it, you can hold it down with the cursor on it, and you can move it. So what it's saying is y is 6.16, etc., times by x plus 41.25. Now, this is now in the form of a straight line, which it should be, of course, just like we've done previously. But what you want to make sure you do is when you're transcribing, when you're moving this onto the paper, onto your answer sheet, perhaps, or in an assessment, don't use the letter Y. The calculator will do that to indicate it's referring to this axis, but don't use Y because we didn't put Y there, we put mark. So you'll actually write mark equals. You'll have to round this off generally. So look in the question for how many decimal places you need. Probably just 2 would be enough, given that this has come out as 2 decimal places. I wouldn't use X, I would use time. Now, in your notes, you can see that that's happened as well with this one. This one that's been plotted for you in the example has got CO2, so probably carbon emissions, carbon dioxide emissions. And instead of writing y equals mx plus b or mx plus c, you can see here that instead of y, we write what's on the y-axis, and instead of x, we write what's on the x-axis, which in this case was income. You'll also notice as well, this one, it's been looks like it's been written the other way around, but look at the what's being multiplied by x. It's 0.4 times x, so that's been written first. And then the y-intercept, which is here, is 1.4. So they are the steps just there. Just make sure you refer back to them if you need to as you're doing this, particularly as you're practicing, because you're not expected to know all the steps off by heart when you're first starting out, but perhaps after all the practice that you do, you'll be able to do it without even looking at this step-by-step process. So I'm going to leave it there so that you can have a go now at finding that least squares regression line using some of the examples that you've been provided with in the exercises.